So here's a typical related rates problem, the kind that you may see. This says a man 6 feet tall walks at a rate of 5 feet per second toward a light pole that is 16 feet tall. So the first question is, at what rate is the tip of his shadow moving? And B, at what rate is the length of his shadow changing when he is 10 feet from the base of the light? So the first thing we do is draw a picture, a diagram, to help us understand this problem. So on the far left end of the triangle, we have the dimension of 16. That represents the light pole. The man is 6 feet tall, and so he's represented by that vertical line that's inside the triangle. And his location along the base, the tip of his shadow is all the way over at the far right end of the triangle. Now, his position inside of the triangle divides the triangle into two length segments, Z and Y. And what we notice is that if we add Z and Y together, we get X. So X is equal to Z plus Y. Now, the problem, if we go back and look at it, the problem says that he's walking at a rate of 5 feet per second toward the light pole. And so that means that the position or the distance Z is decreasing. So we can actually say that dz dt, which is the rate at which the number Z is decreasing, is equal to -5 feet per second. Okay, another thing that we can say about this triangle is we can use the geometry of triangles, similar triangles, to make a relationship. One thing that we can say is that 16 over x is equal to 6 over y. So the vertical side of the big triangle is equal to the horizontal, or divided by the horizontal side of the big triangle, is equal to the vertical side of the small triangle divided by the horizontal side of the small triangle. And then we can multiply both sides of the equation by x and by y, and we get 16y is equal to 6x. If we divide both sides of the equation by 6, we get x equals 16 over 6 times y, which is equal to 8 over 3 times y. Okay, so using that then, if we take the derivative of this equation, let's simplify that equation. That's the same thing as x equals 8 over 3 times y. Now, keeping in mind that both x and y, and z for that matter, are quantities that can change with time, then we can say that dx dt is equal to 8/3 times dy dt. So we've got that so far. Okay, and then going back to this equation up here at the top, x equals z plus y. If we take the derivative term by term, we get dx dt is equal to dz dt plus dy dt. And so I think what we're going to do here, the first part of the problem said, let's find the rate at which the tip of the shadow is moving. Now, it turns out that dx dt is equal to the rate at which the tip of the shadow is changing. Okay, so again, dx dt is the rate at which the tip of the shadow is moving. Now, if we go back for a moment, we had dx dt is equal to 8/3 times dy dt. Another way of looking at that is that dy dt is equal to 3/8 times dx dt. And keep in mind that we also know that dz dt is equal to -5. So let's go back and borrow this equation, okay, and we'll make some substitutions. We know that dx dt is equal to dz dt plus dy dt. Okay, but dz dt is -5. And dy dt is equal to 3/8 times dx dt. Now, if we subtract 3/8 dx dt from both sides of the equation, we're going to get 5/8 times dx dt is equal to -5. Multiply both sides of the equation by 8/5, and we're going to get dx dt is equal to -5 times 8/5, which is equal to -8 feet per second. So that's the rate at which the tip of the shadow is moving. So the second question was, at what rate is the length of his shadow changing when he is 10 feet from the base of the light? Okay, now if we go back and look at the diagram, the length of his shadow is y. So y equals the length of the shadow. And that means that dy dt is the rate at which the shadow is changing. Okay, so dy dt is the rate at which the length of the shadow changes. Okay, so now we said before that dy dt is equal to 3/8 times dx dt. In fact, that was from this part of the equation right here. So if we go back over here, dy dt is equal to, what did I say it was, 3/8 times dx dt. But we just calculated in the previous part that dx dt, down here in the corner, dx dt was -8 feet per second. So that means that we have 3/8 times -8. The 8's are going to cancel, and so we get dy dt is -3/8, is -3 feet per second. So that's the rate at which his shadow is changing. So again, this is a fairly typical related rates problem, and hopefully this helps you to see how to do it.